This video contains most frequently or repeatedly asking equations. We summarize this equation after analyzing the previous year question papers. This will definitely help you guys to perform well in the upcoming VSSC Technical Assistant exam of Electrical. All the best, guys. Let us come to the video. First one, back EMF of DC shunt motor. EB equal to V minus IARA or EB equal to NP-Z5 divided by 60A, where V is the terminal or supply voltage, IA is the armature current, RA is the armature resistance, N is the speed, phi is the flux per pole, P is the number of poles, Z is the number of conductors. Second one, the range of electrical conductivity for semiconductor is 10 raised to minus 6 to 10 raised to 4 ohm centimeter inverse. The electrical conductivity of semiconductor increase with the rise in temperature as more electrons can jump to the conduction band. The range of electrical conductivity for insulator is less than 10 raised to minus 10 ohm centimeter inverse. The energy stored in the capacitor E equal to 1 by 2 Q square by C. We know that charge on a capacitor Q equal to CV. Substituting this equation in energy stored in the capacitor equation, we get E equal to 1 by 2 CV square. Again substituting CV equal to Q, we get energy stored in the capacitor is 1 by 2 QV. We can use any of these equations in the question according to the given data, where Q is the charge stored on the capacitor, E is the energy stored in the capacitor, C is a capacitance value, B is the electrical potential difference. Sixth one, classification of turbines. Tangential energy is impulse, head is high, 300 meter and above, specific speed is low, that is 0 to 60 rpm. Example is Pelton wheel turbine. Radial energy is reaction, head, medium head, 30 meter to 300 meter, specific speed medium, 60 to 300 rpm. Example Francis turbine. Axial flow energy is reaction, head is low, less than 30 meter, specific speed higher. Then next classification is 300 to 600 rpm. It is propeller turbine. Next one is 600 to 1000 rpm, which is Kaplan turbine. Seventh one, the total number of coils per phase per coil is total number of coils divided by number of phases into number of poles. By heart this equation. Number of parallel path A equal to number of poles P in lap winding, whereas number of parallel path A equal to 2 in wave winding. Types of damping and instruments used. Air friction damping, moving iron, MI and EDM, electrodynamometer instruments. Fluid friction damping, the instrument used is electrostatic voltmeter. Eddy current damping, PMMC, permanent magnet moving coil and induction type instruments. Electromagnet damping, fluximeter. Series RLC circuit. The net impedance Z equal to R plus J XL minus XC, where XL is the inductive reactance which is equal to omega L. XC is the capacitive reactance 1 by omega C. So that the inductive reactance is directly proportional to frequency and capacitive reactance is inversely proportional to frequency. XL directly proportional to F and XC directly proportional to 1 by F. Resonance curve of series RLC circuit. This is the resonance curve of series RLC circuit. At below resonant frequency, XL is low and XC is high. Circuit behaves like a capacitive circuit, that is leading power factor. At a resonant frequency, XL and XC are equal. Circuit behaves like a purely resistive circuit. Unity power factor. At above resonant frequency, XL is high and XC is low. Circuit behaves like an inductive circuit, that is lagging power factor. Extra note is that in a series RLC circuit, the impedance Z equal to root of R square plus XL minus XC whole square. At a resonance, the magnitude of inductive reactance is equal to capacitive reactance. At this condition, Z equal to, that is total impedance equal to R. Hence at resonance, impedance is purely resistive and it is minimum. As impedance is minimum, the current is maximum. As impedance is purely resistive, the power factor is unity. 12th one, the maximum torque of a three-phase induction motor under running condition is inversely proportional to rotor reactance and standstill. The maximum torque of an induction motor is independent of rotor resistance, but slip at which maximum torque occurs depends on rotor resistance, and they change on adding the additional resistance to the rotor circuit. Therefore, maximum torque is directly proportional to supply voltage and maximum torque is inversely proportional to rotor reactance. Hence, the maximum torque is dependent on the supply voltage and reactance of rotor and is independent of the rotor resistance. 13th one, the maximum power transfer to the load is Pmax equal to Vth square divided by 4 Rth. Shunt resistance Rsh equal to Rm divided by I by Im minus 1, where Rm is the internal resistance of the coil, I is the total current, Im is the full scale deflection current. KCL. The summation of all currents at any junction or node is equal to 0, or at any junction or node, sum of all leaving current is equal to sum of all incoming currents. 16th one, the motor used in household refrigerator is single phase induction motor. Applications of different single phase induction motors. Split phase motor application is shop grinders, washing machine, belt driven conveyors. Capacitor run motor, compressors, conveyors, refrigerators, air conditioners, ceiling fans. Shaded pole motors application, hair dryers, toys, record players, small fans, electric clocks. AC series motor application, sewing machine, table fans, food mixers. 18th one, the speed of the alternator or synchronous speed ns equal to 120 f by p, where f is the frequency, p is the number of poles. Rotor speed nr equal to ns into 1 minus s. Slip s equal to ns minus nr divided by ns, where ns is the synchronous speed, s is the slip and nr is the rotor speed. Rotor input or air gap power, Pin equal to pg divided by 1 minus s, where pg is the gross mechanical power output and s is the slip. Stator input P equal to Pin plus stator loss. Motor and its application, DC series motor, traction system, cranes, air compressors. DC shunt motor, lathe machines, pumps, blowers, conveyors, belt. DC compound motors, presses, shears, elevators, rolling mills. Stepper motor, 3D printing equipment and CNC milling machines. What is pole pitch? Pole pitch is defined as peripheral distance between centers of two adjacent poles in DC machine. This distance is measured in terms of armature slots or armature conductor come between two adjacent pole centers. This is naturally equal to the total number of armature slots divided by number of poles in the machine. A pole pitch in electrical machine is equal to 180-degree electrical. Hall voltage states that if a specimen, that is metal or semiconductor carrying a current I placed in transverse magnetic field B, an electric field is induced in the direction perpendicular to both I and B. Hall coefficient RH equal to 1 by rho, which is equal to 1 by Ne, where rho is the charge density, that is sigma by mu, and N is the charge concentration. E is the electron, charge of electron, and sigma is the conductivity, mu is the mobility constant. Hence, the Hall coefficient becomes RH equal to 1 by Ne, which is equal to mu by sigma. The Hall effect provides information on the sign, concentration and mobility of charge carriers in the normal state. A positive sign for the Hall coefficient indicates that the majority carriers are holes and the semiconductor is p-type. A negative sign for the Hall coefficient indicates that the majority carriers are electrons and the semiconductor is n-type. Applications of Hall effect. Hall effect can be used to find carrier concentration, type of semiconductor, conductivity and mobility. Transformer. In a step-up transformer, secondary side voltage and turns are greater than primary side. In a step-down transformer, primary side voltage and turns are greater than secondary side. Turns ratio N of a transformer is N equal to I1 by I2 equal to V2 by V1 equal to N2 by N1, where N1 is the number of turns across primary, N2 is the number of turns across secondary, V1 is the primary voltage, V2 is the secondary voltage, I1 is the primary current and I2 is the secondary current. In DC generator having P number of poles and speed of n rpm, frequency of magnetic reversal equal to Pn by 120. Boolean algebra laws. Inverse law. In AND form it is A dot A dash equal to 0. In OR form it is A plus A dash equal to 1. Commutative law. In AND form it is B dot A equal to A dot B. In OR form it is equal to B plus A equal to A plus B. Associative law. In AND form it is A dot B dot C equal to A dot B dot C. In OR form it is equal to A plus B plus C equal to A plus B plus C. Distributive law. In AND form it is A plus BC equal to A plus B into A plus C. In OR form it is A into B plus C equal to AB plus AC. Absorption law. A into A plus B equal to A, and in OR form it is A plus AB equal to A. De Morgan's law. AB whole bar equal to A bar plus B bar. In OR form it is A plus B whole bar equal to A bar into B bar. Identity law. 1 dot A equal to A in AND form and 0 plus A equal to A in OR form. Null law. In AND form it is 0 dot A equal to 0 and in OR form 1 plus A equal to A. Idempotent law. A dot A equal to A and A plus A in is A in OR form. To convert delta to star connection, we can use this equation. RA equal to RAB into RAC divided by total resistance, that is RAB plus RAC plus RBC. RB equal to RAB into RBC divided by total resistance, RAB plus RAC plus RBC. RC equal to RBC into RAC divided by total resistance, which is equal to RAB plus RAC plus RBC. There is a note. If the resistance of equal value, then conversion is much simpler. That is, we do not want to use this equations. We can directly use equations like for star to delta connection we can use R equal to 3R. For delta to star connection we can use R equal to R by 3. 30th one, voltage regulation is the change in secondary terminal voltage from no load to full load at a specific power factor of load, and the change is expressed in percentage. Voltage regulation equal to V0 minus V divided by V0 into 100%, where V0 is the no load secondary voltage and V is the full load secondary voltage. Value of earth resistance station. For large power station, maximum permissible resistance is 0.5 ohm. For major power station, maximum permissible resistance is 1 ohm. For small power station, maximum permissible resistance is 2 ohm. For all other cases, maximum permissible resistance is 8 ohm. The earth continuity inside an installation, maximum permissible resistance is 1 ohm. 32. Form factor is defined as the ratio of the RMS value to the average value of an alternating quantity. Form factor equal to RMS value divided by average value. Crest or peak factor is defined as the ratio of maximum value to the RMS value of an alternating quantity. Crest factor equal to maximum value divided by RMS value. The form factor and crest factor for different waveform is: for sine wave, RMS value is 0.707, crest factor is √2 or 1.414, and the form factor equal to 1.11. For triangular wave and sawtooth wave, RMS value equal to 0.577, crest factor equal to √3 or 1.732, and form factor equal to 1.154. For square wave, RMS value, crest factor, form factor all are 1. Ferranti effect. The effect in which voltage at the receiving end of the transmission line is more than the sending voltage is known as the Ferranti effect. Such a type of effect mainly occurs because of the light load or open load, that is no load at the receiving end. Ferranti effect occurs when the current drawn by the distributed capacitance of the line itself is greater than the current associated with the load at the receiving end of the line, that is during light or no load. The Ferranti effect on long overhead line is experienced when the line is slightly loaded. 34. Current chopping. Current chopping in circuit breaker is defined as a phenomenon in which current is forcibly interrupted before the natural current zero. The voltage across the capacitor during current chopping V equal to 1 by root of L by C. Current chopping is mainly observed in the vacuum circuit breaker and air blast circuit breaker. There is no such phenomenon in oil circuit breaker. 35. Measurement of power of three-phase balanced circuit using two wattmeters. Reading of both wattmeters are, the equations using are W1 equal to root 3 Vp Ip cos 30 degree minus 5 and W2 equal to root 3 Vp Ip cos 30 degree plus 5, where Vp is the voltage across pressure coil, Ip is the current across pressure coil, phi is the phase angle. In 2 wattmeter method, the power factor can be calculated as cos phi equal to cos tan inverse root 3 W1 minus W2 divided by W1 plus W2. In wattmeter method, the total power can be calculated as P equal to W1 plus W2. The table shows the W1 reading and W2 reading and the conclusion according to the phase angle. For 0 degree phase angle, power factor is 1 and W1 reading and W2 reading we can obtain after substituting the phase angle value phi in the equation of W1 and W2. We get for phase angle 0 degree, W1 equal to 3 by 2 Vp Ip and W2 equal to 3 by 2 Vp Ip. Conclusion is that the reading of wattmeter 1 and wattmeter 2 are equal. That is wattmeter 1 W1 equal to W2 when phase angle is 0 degree. For a phase angle phi equal to 30 degree, power factor equal to 0.867. W1 reading equal to root 3 Vp Ip and W2 reading is root 3 by 2 Vp Ip. The conclusion is that wattmeter reading of 1 is equal to 2 into wattmeter reading of 2. That is, reading of 1 wattmeter is half of the other when phase angle is 30 degree. When phi equal to 60 degree, power factor is 0.5. W1 reading equal to root 3 by 2 Vp Ip and W2 reading is 0. That is, one of the wattmeter have 0 reading when phase angle is 60 degree. 90 degree. When phase angle is 90 degree, power factor cos phi equal to 0. W1 reading equal to root 3 by 2 Vp Ip and W2 reading is minus root 3 by 2 Vp Ip. That is, W1 equal to minus W2. One of the wattmeter have negative reading when phase angle is 90 degree. The time required by the microprocessor to complete an operation of accessing memory or input-output device is called machine cycle. The 4 steps involved in machine cycle in order is: first one fetch, second one decode, third one execute and fourth one store. The damped natural frequency of a second order system is omega d equal to omega n into root of 1 minus eta square, where omega n is the natural frequency and eta is the damping ratio. 38. The reflection coefficient equal to ZL minus Z0 divided by ZL plus Z0. Voltage standing wave ratio VSWR equal to 1 plus reflection coefficient divided by 1 minus reflection coefficient. For the ripple counter to count properly, T clock greater than or equal to N into TPD, where and the maximum clock frequency F clock equal to less than or equal to 1 divided by N into TPD, where T clock is the clock interval and N is the number of bits, TPD is the propagation delay. Time constant of RL circuit is L by R. The load impedance reflected on the primary side is RL reflected equal to RL into N square. The phase velocity of a lossless transmission line is Vp equal to 1 by root LC. The characteristic impedance of a transmission line is Z0 equal to root of L by C. Energy stored in coil equal to 1 by 2 Li square and copper loss equal to I square R, where I is the current, L is the inductance and R is the resistance. Coefficient of coupling K equal to M divided by root of L1 L2, where M is the mutual inductance, L1 is the self-inductance of coil 1, L2 is the self-inductance of coil 2. The relation between voltages and the relation between currents of star and delta connection. For star connection, VL equal to root 3 VPH and IL equal to IPH. For delta connection, VL equal to VPH and IL equal to root 3 IPH. Thank you.